okay, in the examples we've been talking about so far, there sort of really is a population. There's a population of courses, and they have a certain number of students enrolled, and it makes sense to talk about the average number of students enrolled in those courses. Or there's a population of women, and some of them have had extramarital affairs, and there really is a number that have had extramarital affairs, and we're trying to estimate that. There are a number of situations where it's useful to think about drawing samples from populations that don't actually exist. And we'll talk about a couple of examples of that. So first one is, suppose I want to know what the average test score would be for some group of students. And I'm going to do that by taking a random sample of students and administering the test to them. Okay? Use that to estimate. What am I estimating? Well, I'm not estimating the test scores of all the students because not all the students have test scores because not all the students took the test, right? I'm thinking about a hypothetical population of what would the test scores have been had all the students taken the test, but in fact they did not, okay? So I'm thinking about drawing a random sample from a hypothetical population that doesn't exist because I didn't do the work, right? Okay. Now, that's one direction. Something that happens even more often is when you start thinking about the effect of a treatment. When you're trying to look at, I give some people a drug, I want to know what's the effect of this drug. And typically what I want to know is the difference between how many people would have gotten better if everybody had gotten the drug. How many people would have gotten better if nobody had gotten the drug? Okay. The example I've got written down here is like SAT training, SAT coaching, right? You coach some students. You want to show that SAT coaching works, right? I work for an SAT coaching company. I want to show that I have this great service and that I'm going to improve your SAT scores by 75 points, okay? So how do I do that? Well, I got to have, I would start with some collection of students. I would take a random sample of them. I would coach some of them. I would not coach the others, and I would compare the average test scores when we were done. Okay? That would be a reasonable thing to do. Okay? How do I know what the effect was on any particular student? I have no way of knowing, right? Because I can't simultaneously coach you and not coach you. So I can't compare your score with coaching to your score without coaching. Yes? Somehow what I'm thinking about is, what would the average score have been had everybody been coached? And what would the average score have been had nobody been coached? And I'm trying to figure out what the difference is between those two averages. But that's the difference between the average of two lists, neither of which exists. Because any given student either was or wasn't coached. You don't get a list of numbers that has that student's test score if they were coached and that student's test score if they were not coached. You don't get both, right? Okay, so there's a hypothetical counterfactual. Yep. You can. The problem with taking the test, coaching, taking it again, is that there's actually some learning associated with taking the test. You have more practice taking that kind of test. You're also 3 months older. Other stuff. It's just hard to tease it apart. So, okay. So this notion of hypothetical counterfactual sampling from hypothetical populations is really useful. One of the ways people think about this, which we'll talk about a little later when we get into the analysis of experiments, is that every student is represented by a ticket, and that ticket has two numbers on it. One number is, what would that student's score be if the student were coached? The other is, what would that student's score be if the student weren't coached? And then we can think about, well, is there any difference between those two numbers? And one way to formulate things is, if coaching makes no difference whatsoever, then for each student, the first number and the second number are equal. My number might not be the same as your number, but my left number and my right number are the same. Your left number and your right number are the same, right? So if coaching makes no difference whatsoever, that's a good model of what's going on.